Dear ladies and gentlemen, welcome to the experience sharing channel of DIVI Group. Today, we will share with you about the issue, the causes of boiler explosions and how to eliminate this risk. And the scope of this sharing will only cover the range of standard industrial boilers using saturated steam. First, let's answer the question what causes can lead to boiler explosions. As you may know, a boiler is a sealed device containing water. The boiler receives heat from the fuel combustion process, causing the water to heat up to boiling temperature, and the water evaporates into steam. When water transforms into steam, it creates pressure inside the boiler. The more steam produced compared to the steam drawn off, the higher the pressure inside the boiler will increase. Now, let's observe this very common event in our daily lives. This balloon will burst if we continue to blow air into it. We notice that when the pressure inside exceeds the balloon's endurance limit, the balloon will burst. The same applies to boilers. The causes of boiler explosions here are basically two reasons. The first reason, if the pressure inside the boiler increases beyond the boiler's endurance capacity, it will lead to a boiler explosion. The second reason, if the boiler's endurance capacity decreases below the operating pressure of the boiler, it will lead to a boiler explosion. Let's analyze the specific causes as follows. For the first reason, the pressure inside the boiler increases due to the amount of steam produced being greater than the total amount of steam used and discharged. When the pressure exceeds the boiler's endurance threshold, it causes a boiler explosion. Here, the amount of steam used refers to the steam serving the production needs of the factory. The steam discharged is the amount of steam escaping through the pressure protection device, commonly known as the safety valve. This first reason also occurs due to a very basic cause as follows. This is an image of boiler in its normal state, with the fire tube submerged in water, and smoke traveling inside the tubes. The tube walls are always cooled by water, so the temperature of the tube walls is usually close to or slightly higher than the water temperature, even though the smoke flow temperature is high. When the boiler runs out of water to the point where the steam-generating steel tubes are no longer submerged in water or the steam-generating surfaces are no longer cooled by water, the temperature of these surfaces will rise to nearly the smoke temperature or the flame temperature that these surfaces come into contact with. At this point, if the operator does not notice and continues to supply cold water into the boiler, the cold water contacting these surfaces will instantly transform into steam at a very high rate. The pressure inside the boiler will quickly increase beyond the boiler's endurance threshold and exceed the response capability of the pressure protection devices, leading to a boiler explosion. We notice in a dry sauna, when we pour a ladle of cold water onto the sauna heater, we will see a strong burst of hot steam. This is because the steam is instantly generated when we pour cold water onto a hot object at a high temperature. Therefore, when the boiler runs out of water for the second time, meaning a part of the steel is no longer submerged in water and comes into contact with flames or high-temperature smoke, the boiler will automatically shut off the entire system and cannot operate in automatic mode to prevent pumping cold water into the furnace. In this situation, if the operator lacks knowledge and understanding of boiler operation and continues to turn on the manual pump to pump cold water into the furnace, it will lead to this boiler explosion phenomenon. This is the most common scenario currently. For the second reason, the endurance capacity of the boiler decreases below the operating pressure of the boiler. The reasons for this can be caused by the following. 1. Welds or steel in the boiler corroded due to physical, mechanical abrasion by the smoke flow inside the boiler. If the boiler is designed with the smoke speed inside the boiler too fast or the boiler is running beyond its design capacity, it will lead to the phenomenon of smoke flow causing abrasion inside the boiler. Especially when we use types of fuel with high ash content like rice husk, coal dust, sludge coal, etc. However, this phenomenon will occur over a long period, so it can only cause steam leaks rather than causing a boiler explosion. 2. Welds or steel in the boiler corroded due to the chemical reaction because the water in the boiler is acidic or alkaline. 3. the temperature of the welds or steel increases beyond the endurance limit of the material. For these second and third reasons, DIVI Group has described and explained very clearly in the video sharing why water treatment is necessary for boilers on the DIVI Group channel. We invite you and your friends to watch it on our channel for a better understanding. 4. The water supplied to the boiler contains a lot of oxygen, causing the oxidation process for the iron and steel, leading to the corrosion of iron and steel in the boiler. This phenomenon is evident in boilers with high working pressure. This is the reason why boilers operating at high pressures are equipped with deaerators to remove oxygen from the feed water, aiming to minimize the phenomenon of metal corrosion in the boiler. Here are the measures to eliminate the risk of boiler explosions. Following DIVI Group's experience, if these 5 practices are well implemented, the risk of boiler explosions can be entirely eliminated. Let's go through them one by one. First, it is essential to use specialized materials for manufacturing boilers, especially for the pressure-bearing and heat-exposed parts. For the heat-resistant steel plate common in the Vietnamese market, materials such as A515, SP450, or similar heat-resistant steels are used. It's crucial to ensure that the material chosen is indeed heat-resistant. For the heat-resistant steel tubes, it's advisable to use materials like C20, A106, A192, or equivalent. It's important to note that these should be seamless heat-resistant steel tubes, not welded ones. The composition of heat-resistant steel is calculated to minimize corrosion from mechanical and chemical factors, so choosing the right material can significantly enhance the boiler's durability and reduce the risk of explosions. Second, the boiler must be equipped with adequate pressure protection devices. Typically, a boiler should have at least 2 safety valves. These valves automatically release steam when the pressure inside the boiler reaches a certain limit. Regular checks on these safety valves are essential to ensure they are functioning correctly, often by manually testing the lever. Ideally, the safety valve lever should be lightly moved once per operating shift. If steam leaks out and the valve automatically closes, it indicates that the safety valve is in good working condition. 2 safety valves ensure high reliability, as the likelihood of both failing simultaneously is very low. The safety valve should be selected with a discharge capacity at least 20% higher than the steam generation capacity of the boiler to ensure complete release in case of overpressure incidents. Additionally, the boiler should be equipped with overpressure protection relays, with at least 1 installed, according to DIVI Group, having 2 is suitable. These devices help stop the entire system if the boiler pressure exceeds a predefined level. Regular checks on these devices, at least once a month, are recommended. For further safety, an additional pressure sensor on the boiler body could be installed. This sensor sends pressure signals to the control cabinet, where protection modes are set up. With at least 4 to 5 levels of overpressure protection, the boiler's safety against overpressure is nearly absolute. Third, a water level sensing system must be installed to measure and warn about the boiler's water level. Water level sensors can be probe-based, with additional flow-type sensors installed. Water level sensors are divided into 4 warning levels. Level 1, full, the pump automatically stops at this level. Level 2, low, the pump automatically starts at this level. Level 3, low, warning 1, low, water risk is low, the pump continues to operate, with a warning light for the operator, and the device operates normally. Level 4, low, warning 2, dangerous, low water level, the entire system is temporarily stopped, with a warning light for the operator, and only operates in manual mode. At level 4, a password could be set for the control system to prevent operators from recklessly pumping water into the boiler, or operators must be thoroughly trained before operating the boiler. Fourth, regular chemical treatment of boiler water is necessary. DIVI Group has detailed guidance on this in their video series. Fifth, regular boiler blowdown is required to remove sediments and slags from inside the boiler, and DIVI Group has detailed guidance on this process on their channel. Boiler operators need to understand one crucial point. Properly following the steps mentioned above is primarily for their own safety. This is also the goal of DIVI Group in creating this video. We hope that our modest knowledge can assist those operating boilers in some way. This concludes the sharing session from DIVI Group. We would be delighted to receive constructive feedback from all of you. Thank you for your attention. DIVI Group, striving to bring prosperity to our partners.